Space, the final frontier. This is the Observer's Notebook, the official podcast of the Association of Lunar and Planetary Observers. Its mission to explore the solar system, to seek out new observations and data, to boldly go where no podcast has gone before. And now the host of the Observer's Notebook, Tim Robertson.
Hello and welcome to episode 209 of the Observer's Notebook, the official podcast of the Association of Lunar and Planetary Observers. I'm Tim Robertson, the host of the Observer's Notebook, and also the coordinator of the training program within the ALPO. Thank you for downloading and listening. The ALPO collects and analyzes observations of various solar system bodies and associated phenomenon, and publishes detailed reports concerning these bodies in its quarterly publication, the Journal of the Association of Lunar and Planetary Observers. This podcast depends upon donations from you, our listeners. Keep it going. If you enjoy what you hear in the podcast, you can donate to it via Patreon. You can start off by giving as little as $1 a month. If you feel even more generous, for $5, you receive early access to the podcast before it goes public. For a monthly donation of $10, you receive a copy of the Novice Observer's Handbook. And for $35 a month, you receive producer credits on the podcast. You can find out more by going to www.patreon.com/observersnotebook. If you'd like to join the ALPO, membership begins at only $22 a year. You can find out more at www.alpo-astronomy.org. And you can also find us on Facebook. Just search for ALPO Astronomy. And yes, this podcast also has a Facebook page as well. Just search for Observer's Notebook. And if you enjoy what you hear in the podcast, please subscribe, and you'll never miss another episode. And now an exciting new podcast, 209, with Carl Hergenrother, and we're talking about the newly discovered comet, Comet Swan. Stay tuned. All right, I'd like to welcome everybody back to this edition of the Observer's Notebook podcast. And we have a new comet in the sky. So that means we're going to be talking to Carl Hergenrother. Welcome back, Carl.
Thanks for having me, Tim.
Yeah, no, Comet Swan. Can you tell us about it, how it was discovered and things?
Yeah, so Comet Swan's a new discovery. It was actually discovered by 3 amateurs using a spacecraft data. Oh. There's a spacecraft up there called SOHO, which is an American-European joint mission that's been up there for over 20 years now. And SOHO stands for the Solar and Heliospheric Observer. Most people may know the SOHO spacecraft because it's the one that's constantly taking pictures of the sun's surface.
Right.
It also has a coronagraph that's really good at not only seeing the corona, but coronal mass ejections, as well as it's discovered thousands of Kreutz sun grazers, kind of like Comet Kawasaki, but really, really small ones. And it's discovered over, I think it's close to 4,000 of these over the course of the last 20 years. But SOHO has another instrument that is actually really good for discovering comets, and that's called the Swan instrument.
Okay.
And what the Swan instrument does is it images the entire sky, except for really close to the sun and really close to the Earth because they're too bright for it. But it images almost the entire sky at the Lyman alpha band, which is 121 nanometers. So basically what it's looking at is hydrogen glowing at the Lyman alpha wavelength. And for the most part, what it's seeing is just the solar wind, the solar atmosphere that's, all throughout the solar system. But of course, comets, as they're going around the sun, release water. That water gets disassociated or broken up by UV from the sun and produces hydrogen itself.
Okay.
So the Swan instrument is really good at detecting the hydrogen coma that surrounds comets. And there's been about almost 24 Swan comets that have been discovered in this data. And almost all of them were discovered by amateurs.
Just looking at the data.
Just looking at the data. Yeah, the data is all publicly available. It may take a few days before it comes online. And they just sit there and they blink through the images, and every once in a while you'll find a little moving object that's not supposed to be there. It ends up being a comet, and that's what happened this time.
Okay.
So this particular comet is C2025 F2 Swan. And as I mentioned, it was discovered by 3 amateurs. The first person to report it was an amateur from Ukraine, Vladimir Bezugli, who has discovered some Swan comets in the past. And on March 29th, he reported to the Central Bureau of Astronomical Telegrams that there is a possible comet in the Swan data, going back to March 22nd. Only a few hours later, ALPO Comets Section contributor Michael Mattiazzo of Australia also reported the comet, again in data going back to March 22nd.
All right.
And then 2 days later, Rob Matson, who lives in California and is also a prolific discoverer of comets in the Swan data, also reported the same comet going back to March 22nd.
Okay.
And starting on April 1st, everyone started talking on the Comets mailing list discussion group about, hey, there's a Swan comet out there. There's a comet in the Swan images. Can we see this from the ground? And it took a day or two, but eventually it was confirmed both digitally in imaging as well as visually.
Okay.
And then once, we got a reasonable orbit for it, people started going back. At the Chinese Xingming Observatory, they found that they had actually imaged the comet on March 20th and March 26th. And a bunch of data was found in Pan-STARRS images, as well as the DECCAM imager on Sierra Tololo, down in the Sierra Tololo 4-meter, going back to September and October 2024.
Oh, my goodness.
And the Sierra Tololo data was actually found by Sam Dean, who was the focus of one of your recent podcasts on the ALPO Observer's Notebook.
Yeah, very cool. Have you met Sam?
I have not met Sam.
Okay, I haven't met him yet. He said next time he comes out to Simi Valley where I live, we'll get together. But interesting kid, man.
Very interesting, and it's amazing the amount of work he does.
Oh, it's mind-boggling.
I mean, it's some of the most important work out there, going back through data that already exists, that's already publicly available, and finding things that were just missed. And a lot of things do get missed because they're kind of at the threshold of detectability.
Yeah.
And sometimes you don't know it's there until you've already found it. So for this particular comet, right now it's still inbound. Perihelion will be on May 1st at 0.33 astronomical units from the sun. That's roughly the average distance between the sun and Mercury. Of course, as you can imagine, as difficult as it is to see Mercury most of the time, when comets get that close to the sun, they're pretty close to the sun in the sky as well.
Right.
It can be fairly difficult to observe. But right now, the comet is a morning object. It's in the constellation of Pegasus, kind of in the northern part of the square of Pegasus. Unfortunately, last night was probably the last night to see the comet without a bright moon. So at least for the next 2 weeks, we're going to have to deal with a bright moon.
Okay.
But the comet's, going to stay in the morning sky at least through close to the end of the month. It's going to get closer and closer to the sun. It's north of the sun, which means right now it's only a northern hemisphere object. You won't see it from the southern hemisphere. But with an inclination of 90 degrees, it's actually it's perpendicular to the Earth's orbit. So it's actually, even though it's north of the sun, it's going to end up crossing the ecliptic on May 4th. And in May, it will transition from being only a northern hemisphere object to being only a southern hemisphere object.
Okay. Yeah, I've seen images of it, and it's got a beautiful tail, too.
Yeah, so it's one of these comets that sometimes is referred to as a lollipop comet, in that, it's got a nice, round, very colorful coma, and then it's got this nice little thin tail, almost like a popsicle stick.
Yeah, that's true. Good description of it.
Yeah, and these comets, I'll have to admit, are some of my favorite. I've observed over 150 comets, and I'll have to admit, usually I'm not observing with the largest of telescopes, but it's rare for me to actually see color in a comet. The only time I see color is if a comet is really close to the sun and dusty, like Shawn Atlas. Right. Even the Atlas comet that happened in January that got really bright, and Neowise from a couple years ago, and it looked very, very yellow. Even though you always see in the press, the great green comet, the great blue green comet. And yeah, they're very colorful in images. But when you look through a telescope, it's like, it's just gray.
It's just gray, right?
But every once in a while, you'll get one of these nice little lollipop comets. And because that head is so vibrantly green or blue-green, that they actually end up being some of the more colorful comets out there. Though to be honest, you still need a large telescope, like
Right.
a large Dobsonian to really suck in the photons and see the color there. So right now, Swan is a little interesting in that we don't know how bright it's going to get because it's kind of been all over the place. When it was observed by Pan-STARRS and DECCAM, and this is only, September, October last year, so we're only talking like 6-7 months ago, it was 21st, 22nd magnitude. So it rapidly brightened. And when people were first getting, visual observations of the comet, April 3rd timeframe, it was around magnitude 9. It had brightened to maybe about magnitude 8.5 by the 5th. And then it had a 1 magnitude outburst and brightened to about magnitude 7.5.
Yeah, we are recording this on April 11th.
Right.
So figure out when you're listening to this podcast, what we'll have in the future.
Yeah. And so, at magnitude 7.5 on April 6th, and if you extrapolated even a conservative brightening trend of 8 log R through perihelion, you end up with a comet that's going to get the 2nd, 3rd magnitude.
Yeah.
But since April 6th, since the height of this outburst, it has actually faded from about magnitude 7.5 back down to magnitude 9.
Is that because of its angle to the sun and the earth, or is it?
No, one of two things is going on. Either one is it just had this outburst, and during the outburst, there was this instantaneous release of a massive amount of dust and gas.
Okay.
And this is now dispersing, and the comet's kind of going back to how bright it was before the outburst. Or alternately, the comet is breaking up, which is unfortunately something that happens much too often for these comets, especially comets that get close to the sun. Now, this one shouldn't really be prone to breaking up because it's dynamically old. It does look like it's been around before, most recently about 70,000 years ago.
Okay.
And it's usually the dynamically new comets, the ones that are making their first time through the inner solar system, that break up.
Right.
But we've actually had quite a few examples of comets that have broken up, even though they're dynamically old. Remember during the height of COVID, there was a C2019Y4 Atlas, which was predicted to be like 2nd magnitude, and it got up to 7th, and then it broke up. And even though it was related to a great comet of the past, sometimes I think what's going on with these dynamically old comets is that what you're seeing is a fragment that broke off a larger piece of the comet.
Okay.
And these small pieces don't really survive their second trip around the sun. So maybe Swan is a small piece of a much larger comet that is yet to come by, or 70,000 years ago. It could have come by 5,000 years ago.
Right.
Sight unseen.
Okay.
So we don't know how bright this comet's going to get. Had the comet not started fading 2-3 days ago, I would have said, oh, it's possible this could be a 2nd, 3rd magnitude comet. And it could be similar to the Nishimura comet that came around a few years back. If I extrapolate 8 log R at the current brightness, and we're assuming it's not going to fade anymore, then it peaks at about 6 magnitude, which is still pretty good.
Yeah, that's pretty good.
And so for observing this comet, right now it is a morning object from the northern hemisphere, and only from the northern hemisphere. It's like most comets that go close to the sun, it's a horizon hugger. Right now, at the start of astronomical twilight, if you're at 40 degrees north latitude, the comet's only up by about 10 degrees.
Okay.
It's going to get closer and closer to the horizon. And by April 25th, actually, it's going to transition from the morning sky to the evening sky. And so, like, first week of May, you'll be able to see it not too far from the Pleiades, but it's really, really low. At the end of astronomical twilight, it may only be up by a degree or two from the northern hemisphere.
Oh, okay.
And by the end of the first week of May, we're going to lose it from the northern hemisphere. But then the southern hemisphere will pick it up, and they'll be able to watch it as it, assuming it's still in one piece, they'll be able to watch it as it recedes from the sun.
Okay. That's good to know.
Yep.
Great. Fantastic. You have anything else on this comet you want to chat about?
Well, the only other thing is if you listen to the 2025 Comets of 2025 podcast, you realize that 2025 was expected to be a little bit of a down year for comets. We had one nice comet predicted for January, which turned out to surpass everyone's expectation. And that was 2024 G3 Atlas. This was a comet that really wasn't even expected to be seen from the northern hemisphere, and at least for a day or two was there in bright twilight at like negative second magnitude. I remember going out one night and not seeing it, and then going out the second night and going, I'll spend 10 seconds and that's it. And within 5 seconds, boom.
Really?
Still a bright sky, 10 by 50 binoculars, magnitude -2.5 with a half-degree tail.
Oh, my God.
Brilliant yellow. I'm like, wow, this is awesome.
Oh, very cool.
Next night went out. It was 2 magnitudes fainter. I couldn't find it. Until a Black Hawk helicopter that flew in front of the comet. And now because my eyes were trained on the helicopter, they were focused at infinity. The comet popped into view.
Oh, my goodness.
So that was pretty cool.
And
then, of course, as we all know, in the southern hemisphere, the comet became quite spectacular.
Right. That's true.
Even though a week or two after perihelion, the nucleus completely disintegrated. But the nice thing about these bright, dusty comets is as long as they survive a few days past perihelion,
they'll be good.
They'll be good. And in the case of some of the Kreutz sun grazers, as long as they survive a few hours after perihelion, they've produced most of the dust that you'll see in the tail. And so even for a month or so after the nucleus broke up, the comet was still a pretty spectacular visual object with its big, long tails.
Okay. Great.
For the rest of 2025, we're not expecting much until the end of the year, where we've got a trio of comets expected to get up to 9th magnitude. But the Mount Lemmon survey did discover another comet in January of this year, C2025 A6 Lemmon. So this was discovered after we had recorded the Comets of 2025 podcast. And this is a comet that will actually, instead of a trio, will now have a quad of good comets at the end of the year.
Oh, good.
It's got perihelion in early November of 2025 at 0.53 AU. End of October, it passes its closest approach to the Earth at 0.6 AU. And this is an object that is mainly going to be a Northern Hemisphere object in October, a little bit into early November, and should peak around 9th magnitude, first in the morning sky, and then by mid-October shifting into the evening sky. So yeah, C2025 A6 Lemmon, instead of having a trio of bright comets at the end of the year, we might have 4 bright comets at the end of the year, with Lemmon joining 210P Christensen, 24P Shomas, and C2024 E1 Vierchos. All comets expected to get to about 8th or 9th magnitude at the end of 2025 into early 2026.
Okay, well, we will get together later in the year then, and when those are coming up, and chat about those again.
Definitely, and hopefully we'll have another nice discovery in the meantime.
Yeah, that's the nice thing about doing this podcast. I mean, I contacted you a couple of days ago, said let's do one on Swan, and here we are doing it now. So we're able to get news information out when it happens.
Yep, you never know. And the great thing about the Swan comet too, for those who kind of bemoan the end of the age of visual discovery, this comet probably could have been discovered visually. So there's still opportunities for visual observers or even just amateurs with wide field, small refractor telescopes or telephoto lenses to pick up these objects, which while they were detected in survey data, they weren't recognized at the time. So sometimes some of these do sneak through the gauntlet there.
That's true. Well, there are not as many visual searchers of comets as there used to be back in the day.
No, and the thing is, even though this was a visually discoverable comet, the frequency of visually discoverable comets is maybe once every 5 to 10 years. So I can understand why people are saying, either I'm not going to try, or I'll just try digitally, where at least I can go fainter and increase the chance of finding something.
Well, that's the trend now. So,
yep.
All right. Well, Carl, this has been great again.
Thanks, Tim.
All right, and we will be talking later.
Definitely.
All right. Take care.
Okay.
All right, well, that'll do it for this episode of the Observer's Notebook podcast. I want to thank Carl Hergenrother coming on today and giving us a briefing on the comet in the sky right now, Comet Swan. Get out there and observe it. And if you see it, send your reports to the ALPO Comets Section. We really appreciate it. We upload new episodes of the Observer's Notebook on the 1st and 15th of every month. You can subscribe to us on iTunes. If you do, please rate us and review us. I'd really appreciate it. You can also listen to us on Apple Radio, iHeartRadio, Soundcloud, Spreaker, Google Play, Stitcher, Amazon Echo, Spotify, and the podcast is also available on the ALPO YouTube channel. You can help support the podcast by donating to via Patreon by giving up to $35 a month, where you'll receive 1 year's membership to the ALPO and producer credits on the podcast. With that, I want to thank the producer of this podcast, Steve Siedentop, and Michael Moyer for their generous support. The link for Patreon as well as the link for the ALPO is in the show notes. If you'd like to get a hold of me, my email address is cometman@cometman.net. Until next time, hope that you always have clear and steady skies. Thanks for listening.